Hello everyone, good evening.
Good evening. Good evening, Ishan. Good evening, everyone.
Good evening.
Okay, so today we have mock session for quiz 2. How's the preparation? I know.
Going good, sir.
Okay, so we will go question by question. Right? I think there are around 19 questions, right? Okay. We will go from question 1 to so onwards. Okay. Okay. Any doubt in question 1? Anyone?
No, sir.
No, sir.
It's you just have to plug in the formula for covariance. That's it.
Sir, we have to remember all these formulas, no?
Yes, you have to.
This is the only biggest task.
Sample covariance, you also have to remember that its denominator is n-1 and not n. Right. Okay, moving forward. Any doubt in second question? If anyone have, just raise your hand or something. This question is also, I think you have done a lot of questions like this. Checking
Yes,
the frequency, column relative frequencies, right?
Sir,
just one thing can we quickly recap. When we say that there is a association between gender and willingness, how
Yes,
do
sir.
we
Association.
identify that?
yeah, sir, exactly. Can you just give a small recap of how do we...
Association.
Okay, whenever all the row relative frequencies or column relative frequencies are similar, we say that there is no association. Okay, if you look at this one, yeah. Okay, so suppose I think this was a scenario. Yes and no. Here it was 15, 15 each. 15 and 40, right? So this is the data given to us. So I'm going by row relative frequency. You can try by column relative as well. It's up to you. Okay. So for row relative frequency, you see that the sum of first row is 55, second is 30, and this first column sum is also 30. This sum is 55, and the grand total will be 85, right? So for row relative frequency, you all know how to compute row relative frequency?
Yes, sir.
Yes, sir.
Sir, row frequency by row total.
Yeah, so it would be, for first it would be 15 divided by 55. Then it would be 40 divided by 55. Then it would be again 15 divided by 30 and 15 divided by 30. And for the total, it would be 30 over 85, 55 over 85, right? So if you check here, for female, it's coming out to be 0.5 over here and 0.5 over here. And this one would be something close to, I think, one for something 0.27, and this one would be 0.73. So you see that here.
So if these values are all equal, there is no relation between the both.
Yeah, there is, these two values are not similar. These two
Yeah,
values are not
normally
similar.
I'm checking, sir. I mean, if these are similar, there is no relation.
Yeah, if these are not similar, there is an association.
Yeah, okay.
Okay. Yeah, that's clear.
Hello, sir.
So we have to check both column and row, or just one will work?
Just one will work.
Sir, here I can see that for first row it is clearly different, and I can find that that it is associated. But let's assume in place of 40, it is 18.
18, okay.
Then Again, it
we
will
won't
depend.
give you such ambiguous data where either you will get much significant difference or no difference at all. The data would be like that.
Is there anything like if there is any this percentage of difference will be there, then we will
Then it's
consider.
up to person. In practical, it's up to you whether you want to consider or not, like how much difference you want to consider. So that becomes something subjective. But whenever there is clear difference like that, it means yes, there is an association. So we
Sir,
want such close calls. Yeah.
sir, you have taken the row relative frequencies, so the comparison should be within rows, right?
Yeah. No. Within rows, so yeah, this row is 0.27 and 0.73, right? And second
Yes.
row is 0.5 and 0.5. So these two not same, right? Not similar as well. This value is compared with this is compared with this.
So I'm
When we
comparing the
take row
rows.
relative, when we take row relative, then we compare column frequency.
Yeah.
And when we take column relative, then we take rows.
Yeah, then you do that. Okay, is it clear or any doubt in it?
Yeah, sir,
Sir,
it's
can
clear.
you explain this association with respect to the conditional probability?
Conditional probability?
Like the 15 by 55 that you are writing, it is a conditional probability.
No, it is an intersection. It is the that's something different. Like of all the males,
Male and yes.
male and yes. It is something you can say probability of yes given
male,
male.
right?
Yeah.
Yes, so it's a conditional probability.
Yeah, it is something like that. If you make it 15 by 85, so it is male intersection yes.
So actually I'm comparing probability yes given male and yes given female.
Yeah.
With no given male and no given female. If they're similar, that means it is not dependent upon the gender.
Yeah, see, because if these are same, right? Suppose these are same, then it doesn't matter whether the person is male or female here. The probability of being yes is same.
Yes.
So gender doesn't affect my answers. But if they are not same, then we say yes, gender is making some difference. Right?
Okay.
Moving further. We have question number 3. Okay, this one.
So I have a doubt regarding this.
Yeah, sir.
No doubt.
Sir, please explain it.
Okay, so you have to make all the permutation of the word create, okay, and then arrange them in ascending order of alphabets, like dictionary order, one can say. So what will be the 121st word? Okay.
Sir, I appeared in this mock test in time trial.
Okay.
But in my student dashboard, it is showing that you have not appeared.
You have to contact the support team for that. We don't have any control over it.
Yes, sir. I appeared in the time trial when the test was going on in time trial.
Mm-hmm.
But now it says that you have not submitted the test.
You may have. You have to contact the support team for that. Only they handle these issues.
Okay, sir.
Sir, for this mock test, there is any marks in the final?
Some bonus marks are there, grading document. You can check if everything is mentioned over there.
Okay.
Okay, so here we have 1, 2, 3, 6 alphabets in total. If I arrange them in increasing order, it would be something A will come first. Then we will have C. Then we will have E at both 3rd and 4th place, right? And then we have R at 5th and P in the last, right? So if I am doing in dictionary order, my first alphabet should be A, and remaining 5 can interchange among themselves, right? These are some first few words in my dictionary that starts with A will appear first, right? So if I am fixing A over here, I am left with 5 more alphabets. which I can arrange in 5 factorial over here.
Yeah.
But E is appearing 2 times. So you have to divide by 2 factorial because these two are identical, not distinct.
So 60.
So number of alphabet words starting with A are 60. After that, the word starting with alphabet C will appear.
Yeah.
So I'm fixing C over here, and then again remaining 5 can be arranged in 5 factorial ways. And again, we have 2 E's. So 2 identical objects, again it's 60 ways. So in total, we have 120 words completed, right? Next word should start with E, because this is our third, right?
Yeah.
4, 5. So 121st word, right, would be the first word that is made from E, and that would be in ascending order. So in ascending order, it would be A, C, E, R. Right? So that would be my 121st word. 60 words starting from E, 60 words starting from C, and then the first word that is starting from E would be my 121st in ascending order of alphabets or dictionary order. Is it clear or any doubt in it?
Just one quick question. So if we go back to the question, 1 minute, please.
Yeah.
So here the word says create without repetition. Is that the hint that we should take, that E should not be repeated?
No. Without repetition means that you can only use these alphabets and you cannot repeat them.
Repeat the same words.
If E is 2 times, I can use it 2 times. I cannot use it 3 times. I can
Okay.
use only these 6 alphabets. It's nothing like that.
So how did you identify? Because I got this wrong. The reason being I didn't consider that divide by 2 factorial. So that how I would know that that's something we have to do.
No, that's what it's meant by without repetition. I think you missed the revision session of week 5-6 by Professor Usha Mohan. He also covered this concept. So whenever there is without repetition, it means you can use only these alphabets, and that word's alphabets can appear only the number of time it is given. It cannot exceed that number of times. So if E is twice, you can use E twice only, but not more than that. C, you can only use 1. A, you can only use 1, like that.
Yeah, no, but in your answer now you said it's not identical. That's because it's got 2 E's in this word, right?
Yeah.
And that's why you're dividing it by 2 factorial. Otherwise, if it was a different alphabet, you would
Yeah, I
have
would
gone
not have divided.
straight by 5 factorial, right?
Yeah.
Okay, that's what I wanted to understand. That word identical is missing here. That's why we have to do that.
I solved this in a different way. I took 6 factorial ways in total, and then because there are 720 by 6 letters. 720 by 6 is 120. So the 121st one will be starting with A and C. Okay, wait. I did something, but I got the right answer, sir. I don't know.
How can you identify 720 by 6? It start with E. I can't.
I don't know, but
you understood my question, right, Ishan? That's what I'm trying to get to, because it's very easy to
So I think
get it wrong.
I think he's trying to understand the formula, like the thing that you use, that if there is since there are 2 identical E's, so the between them the permutation doesn't matter. So I'm dividing it by 2 factorial. So that's I think he is trying to understand.
Yeah, I think if out of n, let's suppose you have 3 alphabets, right? A, B, and again A.
Yeah.
So if you array, let's take it different. Let's take A1 and A2, right? So number of you can make is, let's say, A1, A2, B, right?
Yeah.
A1, B, A2. And then A2, A1, B.
Yeah.
A2, B, A1, and then last 2 would be B, A1, A2.
Yeah.
And B, A2,
A1. Yeah.
Okay. But
so 6
now
different ways.
You will not be able to differentiate between these 2 E's here, right? It doesn't matter. Right? So if I remove this 1 and 2, because both A's are same for me, it's not A1, A2, right? So you see that two of them becomes the same. Each two pair, like
Yeah.
this and this are same. This and this are same.
Right.
And this and this are same. So total number of cases reduced by 2. Like it's the half. If
Yeah.
in total I was having 6, so now it's only 3 left. So that's why in general I should have 5 factorial, but because of these two is it's halved.
Okay.
16.
Okay. Yeah. This is what I was trying to get to. Yeah. Now I got that.
Sir.
Thank you.
Sir, so what will happen if repetition allowed?
If repetition is allowed, then there would be, I think, you can. Then you can, I think from A's you can have a lot of words, more than 120 even. Like you have to first fix A over here. Then again, any of these 6 can come, right? 4, 5, 6. So 6, 6, 6. So it's 6 to 5 even for the word A. So in that case, question would be different. We won't be asking you 121st word.
It would be 5, right? Not 6.
Yeah, 6 to 5.
Ah, okay. 6 raised to
Yeah. Okay,
5.
Sir. Got your point.
We won't be asking. In this case, to find the 121st word, you have to write the complete dictionary. So
6 power 5 divided by 6 होगा ना sir?
No, not 6.
Divided by 6 factorial.
Repetition is allowed.
Yeah, okay.
So you can put any of the 6, right?
Yeah, okay, thank you.
Okay.
Thank you.
I approached it in a different way, Ishan. Can you correct me? Can I explain in briefly?
Yeah, sure.
There are 6 letters, right? So the total number of ways that it can arrange is 6 factorial by 2 factorial. Am I right?
Yeah.
It is coming 360.
Yeah.
So the total 6 letters are there, 360 by 6. Each letter will take 60 combinations. Like that I counted and I got the same answer. Is it the right way to approach?
Yeah, you can do like that.
Okay, fine. Thank you.
Yeah, I also kind of did the same way. ASC ruled out, so it starts with E and then AC. Sir, I had this doubt, the same question. Number 4.
Number 4, yeah, we're coming to that.
Sir, can I ask in question 3? Supposing
Yeah.
there was repetition allowed,
Mm-hmm.
and we said if we fix A, and then we can have 6 to power 5 possible words. But
Yeah.
then again, that wouldn't that point come in that E and E are not differentiable?
E and D are not differentiable.
I mean, there would be words which would have the same or not. I don't know.
Yeah. I think it would be 5 fishes or 5 something. Or
Sorry?
we have to subtract those cases. We have to reduce those cases as well.
So would it be divided by 2 again?
No. It won't be divided by 2. Think. Okay. Let's see.
So for words which are starting with E, we'll do only 5 factorial, right?
If it's like
Words
first is
starting with E.
2, 3, 4, and 5. Right? So see, then for each I have 5 possibilities, right? Either C can come, R can come, E can come, A can come, or T can come. Or
Okay, so we'll eliminate one E and treat them both as one.
1 or 2. Yeah, I think with repetition we can do that. It won't be an issue, I think. Now if we try for 2, let's say let's try for 3. If repetition is allowed, it would be yeah, you can consider these 5 only. It will eliminate those cases. So.
Okay. Treat both E's as the same.
Yeah. Because in with repetition, it doesn't matter. Really.
Thank you.
So one more doubt.
Yeah.
Suppose instead of T, there was a E. There are 3 times E, let's say.
Okay.
So that time we need to divide by 3 factorial?
3 factorial, yeah.
Okay. Thank you.
Okay, moving forward to question 4. Any doubt in it, or were you guys able to do it?
No, it would be good if we can go through this, please.
I got the answer wrong, sir. I want to know how to solve this.
Okay, so there are two ways to do
I
it.
did 8C3 into 2C2, but I don't.
I did the same thing. I got it wrong.
8C3 into 2C2. Okay. Okay, so what?
No, it is at least, right? You have to go for 8C4 also, 8C5.
Yeah. So in total, there are 10 participants, right?
Mhm.
Out of which 8 has at most 3 star, I think. And remaining 2 don't have, right? So we are selecting 5 in total. 5 participants are to be selected, of which at least 3 should have at most 3 star, right?
Yeah.
At least 3 should be of those 8, something like that. Okay. So at least 3 means I could have 3 of them, 4 of them, or 5 of them. Anything will work for me. So let's start with 3. So I can have 3. I can choose 3 from it, and remaining 2 from here, right? Or I can choose from here. So it would be 8C4 and 1 from here.
Okay, I should add up these cases.
Yeah, or I can select all 5 from here and 1 from here.
Nothing from the last one. Okay.
Okay. Another way to do it, if you can identify it. See, I have to select at least 3, right?
Yeah.
At least 3 means
the total minus the at most 2. Right?
No, at most 2 of these guys, right?
Yeah.
So if I am selecting any 5 of these 10, then I won't get more than 2 of these for sure. There is no case when I will get 3 of them. Either
Can
I
you
will
please
get
repeat again?
Okay, let's look at it. See, there are a total of 10 participants, right? 8 participants satisfy my criteria of at most 3 stars, right?
The question was framed to confuse. I thought I just took the last at most 3 stars and did the answer.
Yeah. Okay, see, so what happens is if you select 10C5, right, it means all the ways you can select 5 participants from these 10, right?
Mm-hmm.
So there would be no case when you have these guys more than 2. Either you will have 0 of them or 1 of them or 2 of them, right?
Correct.
You cannot have more than 2. So in that case, if you have 0 of them, you will have 5 of them. If you have 1 of this guy, you will have 4 of these.
4 of them.
You have 3. So there will be no case when you will be having less than 3 of at most 3 stars guys. So if you directly do 10C5, you will still get the answer.
Oh shit.
One is not clear. 10C5 got the same answer, but 10C5 how it will match?
Because there is no case in which you can get less than 3 of at most 3 star guys.
Okay.
In all the cases, you will get at least 3. There will be no case when you can get 2 of them, right?
Yeah.
Okay.
It's also one way to think of it. Okay. Any doubt in it?
No, it's just some minor changes here and there, and you lose the mark. That's what's worrying.
No, that's why you have EMQ part coming in further questions. Yeah, here. See,
No,
this is
actually, for
a
this question, later on I computed 10C5 and I thought why this same answer is coming when we compute. Now
because
I am
there will
able
be
to
no
understand.
case. Yeah, no case, then where we will have less than 3. So it covers all of them. Okay. Now suppose a few of you. Yeah.
Can you explain it again?
The 10C5 part.
Yes, sir.
Okay. See, you have 10 participants, right? Out of which 8 have at most 3 stars. And 2 are of others category, right? They don't have at most 3 stars. So when you have to choose 5 of them, right? So see, in any case, you will be having either 0 from this category or 1 or 2, right? So if you are having 0 from this category means you have 5 from at most 3 stars, if you are having 1 from this category means 4 from at most 3 stars category. And if you are having 2 from this category, then you will be having 3 from at most 3 stars. There is no other possibilities, right? That's the only possibility you can have. So there is no case where you will be having less than 3 at most 3-star participants. So even if you directly choose 5 participants, the condition will be still satisfied.
Correct. And if it was at most 4, then you couldn't do this because
At
it
most
will
4,
not
yeah.
satisfy.
Yeah,
Yeah,
then
it
you
will
have
not
to make
satisfy.
cases. Yeah.
Yeah. Then you have to go with the first way of doing it.
Yeah.
Okay.
Excuse me, sir.
Yes.
This particular gentleman talked about at most 4 stars. Not of 8 participants have at most 4 stars. If
No,
they are
at least
considering
4
that-
participants. Yes. He meant
Oh.
that.
Okay. So how will we approach that particular type of problem? Because if we got that particular thing in exam, how can we approach that problem?
There is the same thing, right? You have to select 4 of these. At least 4 participant means you can have either 4 people from this category or 5, right?
Yes, sir.
So you have to select 4 from it, 1 from the others category, or you select all 5 from it and 0 from others. So these are the only 2 possibilities.
Okay. And so how will we write this particular situation of choosing 5 people? We will just see 10C5.
Yeah, there's a total number of ways you can select 5 participants out of 10.
Because we are not putting any restriction between how many people we can choose from this particular group and the second.
This is the total number of ways. Yeah. Total ways.
Okay.
In total, I have 10 and I have to choose 5. If the restriction comes in like that, you have to make cases.
So can you explain 5th question? I mean the answers.
Yeah, we'll come to that.
Sure.
So those who got it wrong may have lost all the 3 marks, but the CMQ part is here to cover up. I think it's showing 0 point. It will show 0 point in the quiz as well, but you can consider its weightage to be 1 marks.
Sir,
if you
for
got
question
anything.
4, sir,
Yeah.
sir, it will be 8C3 into 2C3, so 2C2
Yes.
plus 8C4 into 2C1
Yes.
plus 8C5 into 2C0.
Yeah. You
So
can do it like that as well.
just the calculation I have to do, no?
Yeah. Or you can directly do 10C5.
LC5, what is that? I did not get it. Now you were explaining LC5, but I was not able to understand.
Because if you choose 5 participants from these 10,
Yes, sir.
there would be no case when you get less than 3 participants who have at most 3 stars.
Mhm.
There won't be any case. You can look at it. Even if because suppose it is not less than 3, right? Let's suppose there are only, let's say there are 2 people who are having at most 3 stars, right? So in that case, it would be 8C2.
So 10C5 you are telling. Okay, okay, sir, I got it. 10C5 I was listening.
Yeah.
Oh, sorry. Okay, sir. Now I saw it.
This is not possible.
Excuse me, sir.
Yes.
Sir, this the other method you said, I understood, but like it will work only because we have the question has restriction on the 3-star people. If
Yeah.
there was like restriction on the 2-star also, then we won't be able to apply this, right? Like
It
at least
depends on
one
the
should be.
situation. Yeah,
Yes.
at least one you want to do. Like if here it is at most 4, at least 4 people having at most 3 stars, then also you cannot apply this. You have to do this. So within this only particular situation given, this is applied. It won't be applied everywhere.
Like we had to analyze the question and see if
Yeah.
we can do it. Okay, sir. Thank you, sir.
Okay, so for EMQ purpose, okay, see, we are selecting participants simultaneously, right? One after the other. It's not like I'm only doing this or doing this. I'm doing the selection simultaneously, one after the other or at the same time. Without replacement, it is mentioned in the question as well that you have to choose the participants. So as soon as you select one participant, you cannot select it again. So without replacement part, you can identify from the question itself. Order, like it doesn't matter if I pick the first participant first, third participant next, or I pick up the third participant first and then first participant. It doesn't matter. At the end, I have only first and third participants. So in such cases, order also does not matter because we are selecting. Whenever you do combination, order does not matter.
I selected these things will not occur simultaneously. I got confused.
So why not occur simultaneously? Simultaneously means we are doing this thing at the same time. We are selecting 5 participants, one after the other or at the same time, right?
Okay.
So that's a simultaneous thing. Without replacement, because you cannot select the same participant again and again. Okay.
Yeah.
So I have one question.
Yeah.
Like that in this mock test, if the question 4th was wrong, then the 5 would be considered. Like so, like in the quiz 2, there would be some questions like this also. Like
Yeah,
if
the same pattern.
okay, fine.
Yeah, and that's what I'm telling. Even in quiz 2, it will show you the 0 marks for that question, but we will assign it like from the back end. We will make it 1 or 2 marks question. So those who got NAT mark incorrect still have chance to get 1 or 2 marks.
So question 5 will not have same weightage as question 4.
No.
How much will be the value? For example, if it is 3 marks, you will be considering 1.5 marks, or how it is?
No, 1 marks you can say. You won't be losing all 3. You will still lose 2, but you can gain a mark or 2.
Option actually, it's very good option.
But it is MSQ. If you take 1 incorrect step, you will get 0 straightforward.
Yeah.
All have to be
Sir, in
correct.
quiz
All
two,
should be
similar
correct.
question
Yes, sir?
Yeah, the steps you have selected should be correct. If you have selected only 1 step, you will get 1/3 marks.
Okay, sir.
2 for 2 correct, you will get 2/3, and for all correct, you will get 1. But even if one of the selected is wrong, you will get 0. That's
So,
MSQ thing.
even if we select
In case I have answered correct for the last
Question
question,
4.
which you then
This
5 will
question
not
won't
be
be checked.
considered.
Yeah, it won't be checked.
At least here with replacement, without replacement, surely we are able to know.
Yeah, it's mentioned
Yeah.
in the question.
I lost it on the simultaneous and not simultaneous thing because I didn't get what you mean by simultaneous. Whether we are saying all 5 participants will be picked together or it will be one after another.
Yeah, together
Actually,
one after the other means
simultaneous
simultaneous.
concept, Musha ma'am explained very well in the
Yeah.
Legal session. You can watch once.
Sir, 13th question.
We are moving serial wise. We'll come to
Okay.
that. Okay, moving to question number 6. Any doubt in it? I think it's pretty straightforward.
Sir, I got it wrong, sir. How to do it also.
Yeah, sir.
See, the simplest way to do is you have to make numbers between 999 and 10,000, right?
Yeah.
So in general, you need to make all the 4-digit numbers possible.
Yeah.
Okay, so total number of ways you can form a number is, in first place, except 0, you can have any of the 9, right? For second, you can have any of the 10 digits. For third also, for fourth also. So total number of ways to do is 9 times 10 cube, which is 9,000, right? Now you have to find.
Sir, please explain once again. 9, 10, 10, 10.
Okay, so using that, the number should be between. There is some disturbance. See, in general, you have to make numbers between 999 to 10,000, right? So all the 4-digit numbers will lie in between them.
Yes.
Okay. So how many 4 digits number can you form in total? For first place, you can have any number except 0.
Yes.
For second, third, and fourth place, you can have any of the 10 digits. Repetition is
10
allowed.
digit you can apply rest of the 3 place, and first place you can apply only 9 digit. Okay.
Yeah. Okay. So we have to find the total numbers that at least 1 5 should be there, right? At least 5 should appear once. So it means that 5 should occur 1 time, 2 times, 3 times, or 4 times, right? So what we can do is we can find those cases where 5 doesn't appear at all. And if we subtract it from total number of cases, we will get those cases where 5 appears at least once, right?
Yes.
So total number of cases is 9,000. And if 5 is not appearing anytime, it means for the first, I have 8 possibilities, 5 is not appearing, and 0 I cannot have. For second, I cannot use 5, but I can use all others. So 9 possibilities, 9.
9.
So it would be 8 times 9 raised to the 4. If you do it, you will get something 316.
9 for
Okay, yes, no.
9 cube.
Sir, we can do it like this also, na sir. First case we can consider as though first place 5 is fixed, and the other 3 is 10 options are there.
Yes, you can also do like 5 is fixed at the first place. For rest 3, you can fill it in. Okay, yeah, in 9 ways, right?
Okay, 9 why, sir? We can take 5, na?
You can take 5. Yeah,
we
but you
can
have,
take 5, 5, 5 also, na sir?
yeah, you have to make cases, right? Where 5 is appearing only once, twice, thrice, and all 4 times.
4.
So within only once, it is possible that it appears at the first place, or it could appear at the, if it appears at the second place, then for the first you have 8 possibilities, 9 and 9 possibilities, right?
Yeah.
Sir,
So
still,
that,
maybe I understood the question it wrongly. That it is saying if at least one time 5 means we can
yeah,
have more than 5 times 5.
yeah, you can have more than 1 5. Yeah,
So if we fix 5 at place 1, so
5
how
at
many
place 1.
options are there for the place 2?
Yeah, 9
Still
options.
10, na sir?
Okay, you are saying like that. Okay, 10.
That
10
is
for
what
it.
I'm considering.
10 for it. Yeah.
Yeah, this is what is why I thought. I took the understood the question.
Okay, but yeah, 5 you can also switch places, right? It could be here, here, and here.
Sir, we can do repetition, na?
You can do repetition, but you are fixing 5 over here, right? There will be
Yes,
some
sir.
numbers when 5 is not at the first place.
No, sir. I'm not. You are. I'm thinking 5 is fixed. So option for 5 is fixed. So we have 10, 10, 10 options. Is it right
Okay.
or wrong?
Yeah, you can say it right.
10 to the power 3. Then next we are fixing the second place for the 5.
Okay.
So 5 is for sure there. And then first place will be 9. And the third place will be 10. And the fifth place will be 10.
Okay. In these cases, there would be many cases clashing with this case. Suppose it's all 5 over here. Here, all 5 over here.
That part we have to consider then.
Yeah, it would all be counted.
So how to consider that part, sir?
That would be very difficult to find it.
So instead of that, we should consider it otherwise where the places of 5 are not used. So
yeah, or you can do it that way as well.
That is better, na? So how many total ways you can consider, then you fix it like that. Yeah. Okay, that is where my problem was there. Okay.
You can also approach it like that. That 5 appears only once, right? So if 5 is appearing at the first place, you will have 9 cube cases, right? If 5 is not at this place, but any of these 3, so any of these 3 places 5 can come. Let's suppose it is at this place. So for first you have 8 options, 9 options, 9 options, right? If 5 move to this place, again you will have this number of options, and 5 move at this place,
Same
again you will have them. So you can do it 3 times 8 times 9 square.
9 square.
That's 24 times 9 square. Similarly, you can do it like that, like that. For all 4, it would be only one case, right? So that would also take some time.
2 cases.
Which 2 cases?
So this way we can avoid the repetition of 5, na, sir?
Yeah, that way you can control.
So 3 into 9 square, okay. Then why 8?
8 because 5 is fixed at second place, right?
We are not considering 0 na, at the first place.
I cannot have 0 and 5 at the first place. So only 8 options are there. Now for the third place, again, I cannot have 5 because 5 is appearing only once and it is fixed at second place.
Why multiply by 3?
Because if 5 move to this place, again you will have this many cases. If 5
Yeah.
move to this place, it again, so it's 3 times the same thing, right?
Yeah, okay, thank you.
Excuse me, sir.
What is for
Yes.
all 4 places?
All from only one case, right? That's the only number you can have.
Yeah, okay.
I also did this, but my answer was coming very less, 2600. Like I only considered only once. I didn't consider twice and thrice.
Yeah, you
I
have to
didn't-
consider that as well.
That also, yes.
Because at least once means it can appear 1 time, 2 time, 3 or
Two
all
times,
4.
yes, sir, yes, sir. So like better way is which you mentioned at the first.
Yeah, that's the easiest way and quickest way to approach.
Got it. Thank you.
Okay. Moving further, again, yeah, this thing. Selection of digits will occur simultaneously. Yes, you are selecting 4 digits together or at the same time only, right? Repetition is allowed. So you can have it with replacement. With replacement represents with repetition only. You can consider it more or less the same thing. Order do matter because number 1, 2, 3 is not same as number 3, 2, 1. So order of in which you arrange the digit do matters, right? Any doubt till now?
Sir, can you please explain about the simultaneous thing? Because
Simultaneous means you have to make 4-digit numbers, right?
Yeah.
So you have to select 4 digits together or one after the other, right? Like fixed at the first place, then second place, you need another digit. Then for third place, you need another digit. So in general, you need all the 4 digits at the same time to complete the number. So you have to select the digits together or one after the other, right? That's what simultaneously means. That you are doing those things at the same time or one after the other or together, right?
So what will be the example of not occur simultaneously? Because मुझे लगता है कि हर चीज में simultaneously ही हो रहा है. So
No, non. If you have done, I think this part 2. Let me show you this question. See, this is some bank locker, okay? And for bank locker code, you have to select pattern. You can select any of pattern A or pattern B, right? And there is some conditions for pattern A code and pattern B code. I'm not going through that. So you have to select the steps applicable for the selection of code type. So you cannot select pattern A and pattern B together or at the same time.
so basically either or के case में.
Either or. So you can neither have pattern A or you have pattern B. You cannot have both at the same. So that's non-simultaneous occurrence, right?
Okay.
Bro, sir, this kind of question came in qualifier, no?
Qualifier? No, I don't think so. This question. Maybe I don't remember.
No, sir, this didn't came in qualifier.
Yeah, I didn't.
Like
But this kind of question was there somewhere, sir.
It is in week 5 graded only.
Oh, okay, yeah.
सर
Yes.
जैसे आपने साइमल्टेनियस बता गए ना, जैसे एक रोहन है, उसके पास 6 गाड़ी हैं, लाइक ही हैज 6 कार्स एंड ही हैज टू चूज in 3 days what are the cars he will select. So in that case also, like simultaneous he is selecting, right? Or
Yeah,
it is not
simultaneously, because to find the number of ways you must have all those 3 selected, day 1, day 2, day 3.
तो सर exactly simultaneous मतलब जब हम like when you are considering all the options together. Hello.
Choices and non-simultaneous.
Yeah, whenever we are
voice is
considering together,
echoing.
it is. Whenever we are selecting together, it is simultaneous. Okay.
Thank you, sir.
Okay. Any doubt till now? Question 7 we have done.
No. No.
Anyone? If anyone, please raise your hand. Yeah. Yes. Your voice is breaking.
Your voice is.
Yeah. You can type it in the chat. Your voice is breaking a lot. Okay, moving forward. Find the number of words with or without meaning that can be formed from 5 distinct alphabets. See, repetition of digits is not allowed. It simply means replacement is not here. Okay. So you are given 5 distinct alphabets. You have to form the words. Any doubt in this? Shall I do this? Or
No, I think this one is okay. Yeah, this one is fine.
320.
Just run through this, please.
Okay. So you should form words of at least 2 alphabets, right? So you can have words consist of 2 alphabets only. You can have words consist of 3 alphabets, 4
4 and
alphabets,
5.
or all 5, right?
Yeah.
So for 2, you can fill the first place with
5.
any of the 5, and for second you have 4 possibilities, right?
Sir,
5.
this is nothing but 5p, 2 plus 5p, 3 plus 5p,
Plus
4.
5p, 4
Yes.
plus 5p5.
It's again,
120, and last one is also 120.
so you can simply add them, right? 320.
Total is 320.
Yeah.
Okay, so if you look at it here also we are selecting the digits simultaneously, right? One after the other to form the words. Repetition is not, yes.
So the question I was asking was difference between simultaneous and non-simultaneous situations, because sometimes I feel little bit of difficulty in defining a particular situation as simultaneous or non-simultaneous.
Okay, see here to form the words, you need to select alphabets first, right? So if you are not selecting all the alphabets together or one after the other, you won't be able to form the words. You must select them like together or one after the other, right? So that's what means simultaneous occurrence.
So what will be defined as a non-simultaneous occurrence?
Okay, so for non-simultaneous occurrence, we check out this example. See, this is the question that there is some bank locker. Okay?
Yes, sir.
And bank locker code could be of either pattern A type or pattern B type. Okay.
Yes, sir.
So you have to select the steps applicable for selection of code type. So you will select either pattern A or pattern B. You cannot select both at the same time or one after the other. You have to go with only one of them. So that's a non-simultaneous occurrence.
Okay, sir.
So you can consider either or as the non-simultaneous things.
Okay, sir. So either we are making this choice or making
Or
another
that choice.
choice.
Yeah,
Yes,
but
sir.
So it will always be either or, right?
Yeah, in most of the cases, yeah. Because see, selection of participant, until and unless you have all the 5 participants, you cannot move forward, right? You must select all the 5 participants together or at the same time to get your solutions. So that's what means simultaneously selection.
Okay. So we should look for this either or type of thing.
Yeah. Okay, that week 5, question 11, it's a good example of non-simultaneous. Here we have all the simultaneous. Okay. Muzammil Afroz, you have raised your hand. Any doubt?
Hello.
Oh, yes.
Sir, my doubt is in question 14, mock test quiz 2.
We are going one by one. Not allowed.
Hello.
We are going question by question. So wait for question 14. No.
I got question 10 wrong, so it would be good if we can go with question 10.
Any doubt in question 9 by now? Anyone?
How order matter here, sir? How order matter here?
Here. Okay.
So how order matter?
See, you have to make the words, right? If I write the word AB or BA, these two are different, right?
Right.
Order do matter. If I am putting A at the first place or at the second place, these are different cases. So that's what order matters.
But in the question it's mentioned with or without meaning, right? I also confused to keep the option only.
Which one? With or without meaning?
Without meaning. Yeah.
The words you are forming should not necessarily be having any meaning. It could be any random words. which are not even in
Mindset is
dictionary.
like here
Sir,
order
actually, I
doesn't
got this
matter
particular
because
question wrong. I think I used
sir,
combinations
in
instead of
question number
permutations.
8,
So
Yes.
without meaning, hence order doesn't matter.
No,
sir,
without meaning means it should not be a dictionary word. It could be any word, any random word. ABA, it is also a word. So without meaning.
sir, in question number 8, one alphabet is not considered as a order, as a word.
Yeah, but that's you have to make taking 2 or more alphabets at a time. We are not asking one
Okay,
alphabet.
okay.
So it means whenever numbers and alphabets are there, order matters for sure.
Now you have to check for it. In such question where you have to form words and numbers, selecting the digits, yeah, simultaneous and order do matter.
What if we're talking about persons?
In persons, it depends. Like if I am giving them some medals, right? Gold medal, silver medal, bronze medal, then order do matter. If I am only selecting them like that, if I am selecting only these, any 5 out of these 10, it doesn't matter, right? If I select participant A first, B second, or if I select participant B first, and then it doesn't matter, right? At the last, I have only AB.
Okay. That means wherever there is rank mentioned, like so
Yeah.
gold, silver, bronze, or something, whereas ranking, then it matters.
Yeah.
Okay.
Even in the case of first, second, third participant, it will matter, right? Like
Yeah.
prizes will be given
Yeah.
first.
In case, yeah. If the
Ishan.
prizes should be mentioned, like the first one is given gold, second one is silver, then bronze, something like that.
Okay,
If you are
I
giving only
normally
prizes,
say, first, second, third prize, then it won't matter.
no, like if it is mentioned that you are having some different prizes for first, second, and third, it do matter, right? But if you are saying you have to give award to only 3 students,
Yeah, so that is general. So
that is general.
any awards will be given to any 3 students, but first, second, third is a place and position which we are
Yeah.
considering,
Yeah.
which would be as kind of a gold, silver, and copper medal kind
Yeah.
of.
So here order do matter, but here don't, because if I give award to A, B, C, or C, B, A, at the end I'm giving award to only them. It doesn't matter.
So is it like permutation and combination type situation, like permutation mein order matters and combination mein
that
just
is
you
what I
have to
was
just
gonna
choose
ask.
3 student, so it doesn't matter.
Yeah, in permutation
Whenever
order
we say
matter.
order matter, it is permutation. Okay, yeah.
So if we just identify we are using permutation or combination, then we can say order matters or not, right?
Yeah, if you can, better than that, if you can identify whether you are doing arrangement or selection. Selection is like you are selecting 5 participants out of these 10. Arrangement means you are arranging digits to form number, right? So if you can identify arrangement and selection, it's pretty easy.
Okay, thank you.
Sir, in this, will it be different when it is a numbered arrangement at first place? Usually 0 will not be allowed. No, sir. In case of combinations or selection, can we say something like that, that 0 is allowed at first place? In which
selection,
case?
it doesn't. In selection order doesn't matter. You could have any of that at any of place, right?
So okay.
Yes.
Sir, question number 10 में actually this question if we can solve by Bayes theorem, but also if in the contingency table I tried this one, but I am getting some different answer. Like instead of 0.55, I get 0.599. So will that be incorrect approach if I use contingency table to find the answer?
No, you have to just make it correctly. You may have made some mistake.
Sir, even with contingency table, the answer will be 16 by 100, no?
I don't know the answer, but yeah, it will be.
The answer is giving under 0.599 it is giving if we are following the
Okay, let's see the
0.16. Answer is 0.16.
Okay, let's do this one. Okay, so 45% of balls are blue. Okay, so I have some balls. Okay, 45% are blue, right? And 55% are red. Okay. After that, among all the balls in the bin, 40% are metallic and remaining ones are of plastic. Okay. So 40% are metallic and 60% are plastic, right? Okay. Next thing it says is a ball is randomly chosen from the bin. Okay. What is the probability that the ball is blue and metallic? Okay. What is the probability that the ball is blue and metallic? So you have to find the probability of blue and metallic, right? Some additional information is given to you is out of all the metallic balls, 60% of balls are red. Okay. Out of all the, there is also separation. 60% of this are red. So 40% of it will be
Here
blue,
I
right?
have one doubt.
Yes.
Here where it mentioned rest are blue balls in the metallic. If
Yeah.
60% are red, correct? But
Mhm.
where it's mentioned apart from R, rest all are blue color.
Understood, no?
That's the only possibility. Either you have blue or red.
But that it's not mentioned, right? In the
It is
question, there are
mentioned. It is in
colors.
a bin. There are
Okay.
45% blue, 55% red. And in out of these 100% balls, 40% are metallic, 60% are plastic. So we are only talking about the distribution within itself.
Okay.
We are not
And
having a
what about
separate.
these plastic balls? Do the plastic balls also have red and balls? Red and
Yeah,
black
but that
balls?
information is not given to me for now.
So no
That
need.
would also have. But I don't know about these numbers for now. Okay. So you see, out of 40% of metallic, 60 are red and 40 are blue. So if I am given that the ball is metallic, then the probability of it being blue is 40%, right? If I know, if it is given that my ball is metallic, then there are 40% chance of it being blue. So given that the ball is of metal, the probability of it being blue is just 40 by 100.
Yes.
Yes, sir.
0.4 into 0.4.
And you know that 40% of balls are metallic, so probability of metallic ball is again 40 by 100. So applying the multiplication rule, you will simply have it 0.4 times 0.4. 116, right? Any doubt in it?
I think
Just
Ishan,
one.
in this case, if we make a matrix, also it would be easier for us to solve now.
Yeah,
Because
I'm coming to
if there
that.
are multiple questions on the same thing, in the matrix we'll go all the answers in one go.
Yeah, we come into that matrix contingency table thing as well. This concept, this way to solve the question, is it clear or any doubt in it?
Clear. Sir, I have a little doubt in this particular situation.
Yes.
Yeah. Sir, I used the three method we have discussed
Three
all
method.
three.
Okay, we can do that. Yeah.
Yeah. But sir, while calculating this particular question, I divided the particular solution, so I got the wrong answer.
Okay, so how did you approach it? Like,
sir, I did the same thing. First, I calculated what will be the intersection of this of having balls blue and metallic, and then I divided by total probability of having metallic balls.
okay, but you don't have to divide it. You only have to find that intersection only.
Sir, even
Yes,
I have
sir,
divided. Even I have divided with the total probability of being metallic.
Why are you just doing it? You have to only find this, right?
Sir, first I have calculated all the blue balls which are metallic.
Okay.
Then that intersection between metallic and blue balls.
Yeah, that's what you have to find only.
Then divided with the total probability of metallic balls.
The question says blue and metallic. It means
Sir,
intersection.
what the question will be if such answer we are planning? What should be the question for such answer type of?
This is given. This information is given to you.
Yes,
what
sir.
is the probability of ball being blue given that it is
so,
of metal?
So that is 0.4, sir.
Yeah.
And then probability of total ball, which are metallic, given that it is like balls which are metallic. B. That is 0.45.
You cannot compute this. Well, because for that you also need to know what percentage of plastic balls are blue. You cannot find probability of B.
So I got my answer 1.14. So
No,
it
how?
came in the range, so that is why I got my answer correct. But my
Yeah, that's
procedure
the
was
wrong
wrong.
approach. Yeah, you cannot compute this probability, right? Probability of blue will be probability of ball being metallic and blue, or probability of ball being plastic and blue, right? So you don't know this probability. No information about it is given. How can you compute this?
Yes, sir. So in my approach, I thought I must use law of total probability. So I calculated B intersection M. Actually, I was calculating B intersection M. But I did was probability of having a blue ball, which I actually got wrong, and then probability of having a blue ball given that it is metallic, divided by the total probability of having a red ball given that it is metallic, means I got the probability of.
You are making it complicated. It's not necessary to go like that.
Sir, can it be done by tree method?
Yeah, if you want to do a tree method. Okay, so this is your bin. Okay.
Sir, I just took the total number of balls to be 100 and did it just by solving it simply.
Yeah, you can do it like that also. So 40% are metallic, right? So probability of being metallic is 0.4, of being plastic is 0.6.
Yes.
After that, you can further split it into red and blue, right?
Yes.
So of being blue within metallic, it's again 0.4.
Yes.
So probability of being metallic and blue, it's 0.4 times.
Easy. Okay.
It's okay. We'll simply do it.
Actually, Ishan, as question started with colored balls, first I tried with colors. I mean, with tree instead of metallic plastic. I started the bin with colored balls and I tried, but I couldn't get. Is it possible?
Yeah, with color you cannot distribute it further, right? You don't have any partition for B and red.
Initially, I tried. I started the bin with divided the bin with colored balls, blue and black, blue and red, and I tried to get. But is it possible?
Yeah, but no information is given to you. You cannot further spread it, right?
Yes, I tried for a few minutes, but
you cannot further split it to metallic plastic. There's no way, but you can split it from metallic plastic to red blue. It depends on what information is given to you.
Okay.
So I mean, the approach should be always that you should be able to expand the tree to get the final answer.
Yeah.
Is that what we are saying?
Yeah.
Okay.
Yeah. Okay. Any doubt till now? Anyone?
No,
Sir,
yeah.
Can we do this question with the Venn diagram?
Venn diagram, you won't be able to calculate the value, but you will be able to find out what you have to compute to get the final answer. But you won't be able to get the final answer than that.
I think for a similar type of question, the instructor has used the matrix method, which is, I believe, the simplest one.
Contingency table is
yes.
Contingency table you can also split it.
Yes, it's
it's up to you. See, you can use Venn diagram, you can use simple probability.
Tell contingency table.
Okay, so contingency table, let's take metallic and plastic or red and blue, I think. Okay, but here also you won't be having sufficient information to fill it all.
So metallic and blue as 40% and 40. 40% into 40.
No, sir, we can fill it up.
We can do, we can do.
We have all the
Because the
total metallic is 40%, total plastic is 60%.
Yeah, total plastic 60, it is 40.
And red is 55, right? Red is
55. 55.
Red is 55.
And the blue is 45.
Okay, and other information given is
one is given a red
Blue
and metallic.
About metallic.
This information is given to you, right?
Yeah.
Yes, red and metallic is.
So for that, but here the probability is of intersection.
Yes.
So for
No,
that you have
actually the
to
matrix which you have drawn, in case if you replace the values, if you put blue and red on the top, and if you put this on the other side, like rows and column names, if you change, then it would be easier for you to do.
no, it doesn't matter, right? It's still the same thing.
Because I tried the way just you have made it, it made me quite difficult to solve during the grade exam. Sorry, the mock exam.
It's all about the practice. Like for some you find it easier.
So
It's not like that.
here if you
Yeah.
put metallic and blue, so it is 40 into 14%, that is 16. And
Metallic
the total
is
for metallic is 40.
Metallic is 40, plastic is
40,
60.
right? Yeah. So here metallic and blue, 40 into 40% will give you 16N or something like that, 16. And 16 minus 40 is 24 here in metallic and red.
Okay, so that's how you can say. Yeah, that's how you can do. Okay, so see,
it will be easy if you take the number of
compute
balls.
these things.
Here it is, this column it is 24.
Here we know metallic and red as 0.6, 60%. No?
See, to compute this, metallic and red as 60, no? Right?
Metallic and blue we know, I believe.
Yes, the metallic and
red
blue.
we know 24. Metallic and red is 24.
If the metallic balls
Out
60%
of
are
all
red.
metallic, 60 are red.
So 60 into 40%,
Metallic
24.
and red.
Yeah, these two informations are given to you, right?
0.4 into 0.6, 0.24.
Yeah. So in the contingency table, all these are intersections. So this one will be M intersection B.
Yes.
This one will be plastic intersection blue. This one will be okay. So if you are doing by matrix and you have only one question, right? So to find this, you are doing the same thing. You are still using the multiplication rule to plug in this value. So no need to make matrix in such questions. You are simply doing that only. You need only this value. If the question has been a bit longer or 2-3 parts, then yeah, you can do it.
Yes, then that would be very beneficial.
Yeah, but in such cases, it's simpler to go with tree diagram or only I think this will multiplication rule will work.
So in matrix, this becomes more simpler if we take the number of balls just.
Yeah, you can do it if you're not comfortable.
Like taking 100 and just taking the balls.
Yeah, there are only 40 balls, 55, 45. You can do it like that. Okay, moving forward. Any doubt on question number 11? I think you guys have done enough of 11, 12 type questions by now.
So can you please explain?
So Ben, it will be better if you go through this problem, sir, so we can just verify our solutions.
I think earlier I've made some mistakes in calculation. That's why I got wrong. But currently I've just solved and I got right.
0.53 is the answer.
Yeah, 0.53 and for 12, 0.28.
So you can discuss it out somewhere else. So you have 3 colleges, X, Y, and Z. The probability that someone is from college X is 0.30. From college Y, it's 0.20. From college Z, it's 0.50, right? This much information is given to me in the first line. Okay. 1 minute.
Then after conditional probability is given like first one is 50% in X, 50% in Y, and 60% in Z.
Yeah, this is a girls probability, right? Probability of girls given at all steps.
Yeah.
Can you tell me the numbers?
50% for X and 40% for Y. 50, sir. 50. And 60% for Z.
60% for Z. Okay. So you have to find the probability that the selected student is a girl, right?
Yeah.
So, but all other possibilities. See, if you look at it, either you will have someone from college X, Y, or college Z, right? Consider this as girls, even G, right? So it is possible that it is selected one as a girl and from college X, right? Another possibility is it is girl and from college Y. And the last possibility is girls and from college Z, right? No other possibility of being a girl. That the selected student is a girl, right? Is it clear till this step?
Yes, sir.
Now using the multiplication rule, you can simply do it.
This question also I did it tree method only. That looks simpler for me.
Yeah, it's up to you. Whatever you want to
Again,
use, you can do it.
instead of doing
Contingency table can be used.
it will be time saving if we just equate it to 100, no sir. So 30,
Yeah,
20,
that approach you can also do. But
yeah,
what
15
happens
girls, 8
is
girls and 30 girls. 53 girls in total by 100, 0.53.
in some rare cases,
yeah, that might.
There is some rare cases, yeah, but that's probability is very less of happening. But yeah, you may get it wrong in some cases, or you might not be able to get it. Like it may go in the fractions sometimes.
Okay.
So you have to look for that. That
Yes, sometimes it goes into
it could go like 15.33 girls.
Yes,
Like
true.
so, that
Then
thing works.
computing will takes much time.
Yeah, so that's becomes something less meaningful or something. But that's a rare case. You can approach like that if you're finding it easy.
Yeah, I mean, saves a lot of time.
Yeah, see, there are many methods. See, if someone is practicing from tree method, that method is best for them. They don't want to do anything else. If someone is doing from contingency table, same for them. They find it easier in every question, whatever be it. They don't want to go to tree method or this method. If someone is going from this method only, they feel that these two methods are complicated and keep doing by this. So it's everyone's personal choice. We have covered all the methods.
But sir, sometimes now that answer does not become equal. Like some differences are not exactly huge differences not there. Let us say 0.55 becomes 0.959. So in that case now, whether you will give
No, it may be some calculation error, but the answer would be same for each and every case. We want these method are nothing but the same. If you look at it closely, these are nothing but the same things.
We are going to calculate with the same formula.
Yeah, the formula would be same at the end of
the
calculation.
So calculation.
It's up to you how you want to understand or simplify the question statements.
Sir, one quick question. So in this case, let's say if you go by tree method, I don't want you to go through it, but what would be the approach? You would start with the college and then you would go with the girl and boy, or you would go with girl and boy and then you would go with college?
I would go with college first and then expand it.
Yeah, that's what I thought. Okay, thank you.
Because that expansion is similar, yeah.
So in this method, we multiply two conditions of having a girl from college X.
Yeah.
So sir, we just what I did was I just multiplied them, and on the denominator I summed the probabilities of selecting a student from a college. That actually summed up to one. I thought sir, actually I drew a Venn diagram first.
Okay.
To simplify and visualize the problem, and then I actually calculated to find the intersection between. So I applied the law of total probability.
Okay.
So sir, actually in denominator it came to be 1, so I got the answer to be 0.53.
Yeah, it would always come 1. Like that, it would always be 1.
Yes, sir. And so when we multiply two probabilities, when it is in a particular intersection and we are multiplying probabilities, simply means that these twos are not affecting each other.
No, it's not like that. No, it's not like that. Even if you go for tree diagram, right? So either it is from college X, Y, or college Z, right?
Yes, sir.
And after that, girl or a boy, right? Girl or a boy. Girl or a boy. So here, if you see the probabilities of college X, which is 0.3, right?
Yes, sir.
Here it is the probability that given college X and a girl. That given it is from college X, what is the probability of being a girl?
Yes, sir.
So when you multiply these two, you get G intersection X, which is nothing but probability of X into this. This is the multiplication rule.
Okay, sir.
And in contingency table also the formula comes is the same. So it doesn't mean disjoint or independent, it's simple multiplication rule only.
Okay,
In
sir.
disjoint, the intersection is 0.
Okay, sir. Now I got it, sir. Thank you.
Okay, any doubt in this question?
Yeah, just the second part of this question.
Second part, okay. But we have to find the second part.
If a girl is randomly selected, what is the probability that she is from college X?
Okay, so we know that the selected one is a girl, right? We
Yeah.
have to find the probability that she's from college X. So if you know the conditional probability formula, it's simply this.
X intersection G upon probability of G.
This
Probability of G we just found out.
And for first, you can again use multiplication rule.
0.15.
Sir, 15 girls in college X, so 0.15.
Yeah, 0.15. I think you have computed something.
0.53.
Simply do it, right? If you are able to do the first part, then I don't think second part would be any trouble. It's a bonus marks, I think. These 3 are nothing else.
So why we not take 15 by 30?
15 by 30. 15 by 30. Why 15 by 30?
Out of 3 colleges we are considering.
Yeah, out of 3 colleges. So the probability of girl, it means the girl could be from any of these 3 colleges, right? X, Y, and Z. So you have to consider all the cases by applying the law of total probability.
So X is chosen by girl, no?
Yeah, if we take 30, then we will include boys also.
The question is, how many number of girls from college X out of total girls?
Yes.
Total girls could, you have to consider all the cases of X, Y, and Z. Right. Okay, any doubt to question number 12? Anyone?
No, sir. 13th. Can we go to 13th?
No, sir.
Sir,
yeah.
I had a doubt in question number 12.
Yeah.
Yes, sir. I actually calculated and got the answer, but I think it's probably the wrong method.
Yes. How did you approach it?
Sir, I calculated P G comma X given that P X given G a girl is selected, we have to find a run. Yes, sir.
That's what you have to find, right? Yeah.
Yes, sir. Yes, I did that. But just here I think I have used, because I am not able to find a solution where I have written it. I think it's probably the best, not the right thing.
Okay, just search for it. I think we can discuss it later then.
Okay, sir.
Okay, question number 13. I think it's simple base theorem. Any doubt in it? Anyone?
So please explain it, sir.
Yes, sir.
So the 13th question, I got 0.8 as the answer. I got it wrong. Can you explain it?
Okay, so there's some machine learning model that
But
detects.
also I'm able to solve with tree method luckily.
So the model detects whether the given image is of dog or not. Okay. So it is found that given an image of dog, the model predicts it to be dog in 95% of cases. Okay. So were you guys able to convert the statements into events? Like, let's say that.
Yeah, dog and dog complement and correct and not correct.
Yeah, so let's say that given the image of dog, model predicts it correctly. It's 95% chances, right?
Yes.
Next thing it says that on the other hand, if the image is not actually of dog, it shows image to be of dog 30% of time. Okay, so I'm given that the image is of not dog. Correct, incorrect. We have to do that. I don't think we'll make correct, incorrect. I think we can define some event that Event D be that the image of dog. Okay. Event A is that model predict it's a dog. Right? And event B could be model doesn't predict dog. Right. So the first case is you are given that the image is of dog and model predicts it correctly. It's 95% of cases. Given image is not of dog, model still predict its dog. That's 30% cases, right?
Yeah.
Okay. Perfect. Suppose an image is randomly selected from a group of 100 images in which 40 are dogs. Okay. So you have some 100 images. So out of these chances that image are of dog is 40 by 100, right? Because there are 40 images of dog.
Yeah.
And not being dog, it's 60 by 100, right? Straightforward. This information is given to you. Okay. If machine learning model predicts it as a dog, what is the probability that it is actually a dog? Okay. Machine learning model predicts it as dog. What is the probability that it's a dog, right? That's what we have to find. So for that, again, if you know the conditional probability, it's this thing, right? If you apply multiplication rule in the numerator, it would be, you can do it like that also, right? So numerator part, this probability is given to you, this is given to you. You can simply find the numerator, right? The only concern is of denominator now. Is it clear till this step?
Yes, sir.
Yes, sir.
Okay.
So for the denominator, we have to add just the next probability, like probability A given D complement into probability D complement.
Yeah. So if you look at Venn diagram, so there are two cases, whether image of dog or not an image of dog. And this is the event A that model predicts it's a dog. So if you look at it closely, it's this region and this region, right?
Yeah.
So first region is D intersection A, and second region is D complement intersection A.
Yeah.
Again, applying the multiplication rule. Probability of D plus.
Okay.
Again, you got it. The denominator, you know the numerator, you can simply plug in the values to find, right? Any doubt in it? Anyone?
No,
Sir, इसमें ना visualization, how to visualize, like once we write the equations, it is pretty simple that we can plug the values. But the visualization, how we can make it, because can you give some simplest way to visualize this, and so that we can draw?
Yeah, see, this is my complete, say 100 images of dog, right?
नहीं सर, equation से आपने जो derive किया ना, तो can you give some simplest तरीका इसमें?
Which equations? This one?
Yeah, this value is now what you brought it. Okay, this is P, D given A value and.
Okay. See,
यहाँ से
if you see, it is found that given an image of dog, right? So we are given that the image is of dog. So given D, right? Model predicts it to be a dog in 95% of cases. So what does it mean that given dog, model predicts it to be dog is 95% cases, right?
Yes.
In the next line, it says, if the image is not actually a dog, it means it is given to you that image is not of dog, but model still predict it to be dog 30% of times.
Okay, the complement of that.
Yeah. And then it is given to you as out of 100 images, 40 are of dogs. So probability of dogs and dog images and probability of not being a dog image, right?
Okay.
You can simply compute it. So these are the 4 probabilities given. Rest we did just simple multiplication rule and computations, right?
Thank you, sir.
Okay. Any doubt till this step? Shall we move forward?
Yeah.
Okay.
Yeah, sir.
Can you hint by tree method?
This one?
Yeah.
Yeah, you can do it. You can do it. Not an issue. Okay, let me just
Sir,
erase
and
it.
just one last 16 question later after this, if nobody has any doubts.
Yeah, we are going question by question.
Yeah, sure.
Okay, see, there are some images, right? Some 100 images, right?
Yeah.
40% are of dogs, right?
Yeah.
And 60% are of not dogs, right?
Are you writing, Disha? It's not visible.
Is it?
It is
No,
visible.
No, sir, it is visible.
Yes, sir, it is visible.
Yes, sir. It is
Okay.
visible.
Next, you can divide it into two parts, right? Model predicts it and model doesn't predict it, right?
Yeah.
Here also. Model predicts dog, model does not predict dog. Model predicts dog, and same, model doesn't predict dog, right? So given a dog image, model predicts it's a dog image, it's 0.95.
5%. Yes.
Given it's not a dog, model predicts
0.3.
0.30 cases, right? So you can simply find the intersection. This is nothing but event A, right? So D intersection A.
Sir, can't see the last line, sir. Can you just scroll up?
Last line, is it?
No,
let me
not
just-
visible in my screen. Little scroll up.
You can just make it full screen, it will be visible.
Okay, let me just do it. Is it now clear?
Yeah, fine.
Okay.
Fine, Isha.
So this is nothing but product of D intersection A, right?
Yeah.
And this is nothing but product of D complement intersection A. 0.30, 0.6. So there is no other possibility of getting A rather than this case and this case, right?
Yeah.
Yes, sir.
So probability of A is nothing but the addition of these two.
Yes. It will come 56.
You can simply add these two, right? So you get the
Yeah.
probability of A. And for numerator part, I think you only need this value.
2 × 3/8 divided by
0.38.
Yeah, you can do it. The calculator is given. You can simply compute it, right? Is it clear or any doubt in this till now? Till question 13, any doubt?
I think the tree method seems to be much more straightforward if you know how to approach it, isn't it?
Yeah,
I don't
every
know,
method
it's
is
just-
simple. See, there are some students who are saying that they find matrix contingency table a lot easier than any other.
So it
They
is
will
the
just-
same thing in different forms, actually.
Yeah, and same thing but
It
different
needs
visualization.
practice. Normally in competitive exams, people used to use tree method only, but it needs practice.
Yeah, don't switch your methods 2 days before exam. Just stick to the method you are using to solve. It's all about the practice. Okay, question 14. It's the simplest question of it.
Yeah.
Anyone, any doubt in it?
No, sir.
Okay. We can skip this one. Question 15. Any doubt?
Yes, sir. Something because probability of A is 0.2, then probability A intersection of B union C must be less than probability of A. But it is given 3/10, 0.3. It can't be, right? I was getting 0.1 actually.
सर 14 वाला थोड़ा सा go through कर लेंगे please.
Repetition we have to consider, na, sir? Yeah.
Sir.
Just by expanding
Yes.
the intersection, I got it easy.
One. I think the probability of A intersection
B union C.
Yeah,
It cannot be less
it
than greater
cannot be
than
less than
probability
probability
of A.
of A. Yeah, it cannot be less than probability of A.
But if we apply the formula, just simple formula, we are getting that only.
You're getting that, but the property of probability axioms
yes,
are not
yes.
satisfied.
Yes.
A intersection something cannot be. Okay, yeah, this question values are wrong then. Yeah, good point. Yeah, thanks for notice. Yeah.
Sir, actually here na B union C, if you convert into D, let us say take D is equal to B union C, and then you can find it out. This answer is coming correct only.
No, the answer is
Theoretically, it's
3 by
correct.
10. Theoretically, it's correct, but
Theoretically correct, but practically
it
it's not.
it don't satisfy the property of probabilities. See, because okay, if you look at the Venn diagram, right? Suppose these are your two events, event A and event B, right? So if you notice that the region of A intersection B must be less than the region of A, right?
True.
Yes.
So probability of A must be greater than probability of A intersection B.
Yes.
But in the given question, it is 0.2 and it is 0.3, which does not satisfy us. So that's I think the values are wrong. That would be something else to satisfy.
Question number 14. Can you please go through one, please?
And also one thing is union should be greater than or equal to the maximum of these, right?
Yeah,
So
that is
I think
also
these two got interchanged. It should be 0.6 and it should be 0.7. Then it had been simpler.
yes.
Sir, question number 14. Can you please go through once?
Question number 14.
Yeah.
Okay. Raju wants to collect rainwater. Okay. 100 meters square. Okay. Okay. See, this
Can
is
we expect this type of questions, sir, in the final quiz 2?
Yeah, quiz 2 pattern, weightage wise, question pattern types is more or less similar to the original quiz 2. Difficulty wise, quiz 2 I think a bit more than this, but yeah, it's more or less the same. Okay, so 1000 meter square is the complete area, right? This is the Raju's area of radius 10, right? So the area of Raju's land will be pi r square, right? This complete area.
Yes.
So it would be 3.14 times 10 squared, which is close to 314, right? Meter squared. So probability that the rain will fall in his land is 314 out of total area. It's nothing but 0.31, right? Approximately. Is it clear?
Yes, sir.
Okay. Okay, so question 15, yeah, it's the values got interchange, it's 0.6 and this one is 0.7, and then you know how to compute this probability, right? Even though.
So can you please go through this question? If we having 0.7 in.
Okay, let's switch the values. Probability of A is 0.2, probability of B union C is 0.6, probability of A union B union C is 0.7, let's say, okay? Then
okay, sir.
Let's consider B union C as event E. So this becomes A union E, right?
Yes, sir.
It's A plus E minus A intersection E, right? A union is given to you as 0.7, A is 0.2, E is 0.6. If I plug in the values A intersection B union C, that's what you have to find, right? You can simply.
Yes, sir. I got 0.1.
I got it, sir.
Yeah, 0.1 will be the answer.
That was.
Okay.
What is the answer?
It would be 0.1. This question here is wrong.
Can I approach this question like this, like A union B union C minus B union C? That will give the bacha kucha part of A, which will be like disjoint set from B union C, and we have given PA, so we can minus that PA minus 0.1.
Let me draw. This is event A. Okay? This is event B. This is event C. Let's say. Okay?
Yeah.
Okay, so you are saying if I take.
If we are given A union B union C and we are given B union C, so if we subtract it, we will get this disjoint set of A, which is not the part of B and C.
Okay, if you subtract complete A union B union C, okay,
minus B union C.
Okay, so you are saying that this region you will subtract from the whole, right?
Yeah. So I will get
you will left with only
yeah,
this part.
this. So if I subtract it from PA, I will get the intersection part, which is the question asked, I think. I will get this part.
Yeah, you will get it. Yeah.
This is exactly you want, right?
Yeah, you can do it.
Okay, thank you.
Same I did.
Can you please show the calculation part again for this question?
Calculation part.
Is it erased what? No, I got point at
This part.
0.3.
Yeah, 0.3 because the values are entered in question. It should be 0.6 and this should be 0.7.
Yeah, as per the question data, it's 0.3 only, right?
Yeah.
Okay, fine. Thank you.
Because the value of union cannot be less than the maximum of these two.
Yes, understood.
Can we flip back to that one more time, please? Just wanted to note that down.
This one?
No, the calculation part, please.
Okay, yeah.
So it's saying probability of B intersection B.
Okay, it's not like Quiz-2 will be more difficult or something. It's just more or less the same as mock. We try to keep the pattern and everything same.
Sir, at last, can you just explain the round table and seating arrangement? Just got confused.
The round
Seating arrangement calculation.
Sitting arrangements.
When two people has to sit together and.
Yeah, I think we have these questions coming. I think or not. I'm not sure.
No, it's not there in this.
Okay.
No, sir,
Then
it is in question number 17.
It is, right? Yeah. Question 17. We will do it. Okay, moving forward. Yeah.
So syllabus for quiz 2 is 50-50 of week 1 to 8.
Complete syllabus of week 1 to 8 with 1 to 6 where 50% and 7, 8 50%.
In 17 question, they are not sitting in a round table. They are sitting in a row.
Yeah, we can do that round table as well.
Just consider that point also.
Yeah.
We can consider in that also.
After that, we will do. Okay, just give me a minute.
The intersection one, can we just scroll one more time? I just wanted to see how easily we can calculate it, because the diagram the Venn diagram was not very clear.
Just keep a bracket for B union C in A union B union C. That's
Simple. A union B, take B as B union C. A union B is equal to A plus B minus A intersection B. You substitute the values, you'll get it.
Okay.
Okay. Moving forward, question 16. Is it clear or any doubt in it?
Sir.
Yeah.
We need the 16th one. I mean, I need at least.
Okay.
I got it 1 by 4 for what reason I don't know, but the answer is 1023 by 20.
Yeah. See, for each question you can attempt it in 4 ways, right? They all have 4 options.
Yeah.
For attempting first question, you have 4 ways. For attempting second question, you have 4 ways. Attempting third question, you have 4. Similarly, attempting fourth. So in total, you can attempt the paper in 4 issues or 5 ways, right?
4 power 5. Okay. So repetition is allowed.
Repetition, it's like, yeah, you can select option A in all the questions. Option A, first 3 and B. So in total, you can attempt paper in 4 issues or 5 ways. Yeah. Out of which only one way to get all the correct, right? Like suppose for question A, option B is correct. So you must take option B. You must select it. It can be done in only one way. For question 2, let's say option A is correct. So you need to select that. So getting all the correct, it's only one way.
Okay.
Probability of getting all correct.
So whole minus 1 by 1024. Okay.
Yeah.
Okay, sorted.
So will not get all answers correct. It's just that 1 minus getting all correct.
Yeah, exactly.
Okay, question numbers. Okay, any doubt till question number 16?
No.
No, sir. So actually, in question number 15, the concept is same, but I have considered that the total number, each probability is 1/4, of getting that, and I've done 1 minus 1/4 to the power 5, like that.
Which question? In this question?
15, yeah, 16. This one.
Yeah.
1 minus 1/4 to the power 5, because it is 1 minus that all are correct. That is the concept that you are telling, right?
Yeah.
Yeah. Okay.
So question number 17. In a family, there are 4 boys, 4 girls, 8 seats. Okay. And those who have attended revision session has already this question 1, 2, 3, 4. Okay, so there are 8 seats, right?
Yes, sir.
Yes, sir.
No 2 girls should sit together. So it is possible if I place all the girls in the odd places.
Yes, sir.
And then
Or in
boys,
the even places.
or other ways, I place all the girls at the even and boys at the odd, right?
Yes, sir.
So for the first case, the number of ways is I can arrange these girls in 4 factorial ways and then these boys in 4 factorial ways, or this case 4 factorial times 4 factorial, right? So it's something 2 times 24 squared. 2 times 576, right?
Hello, sir.
115.
Oh, yes.
The question only says the girls cannot be together, but the boys can, no?
Yes,
Okay.
in that way we are getting
Yeah,
4
that
more
way.
combinations.
Like
No,
a girl and
possible. If
We'll
no
get-
girls are together, boys can't be together.
Okay, let's say
Three more.
okay, let's say the two boys are at the first 2
Boys
places, right?
and in
no, sir,
yeah.
first a girl, then 2 boys, then a girl, then a boy, like that.
Sir, there are 3 more possibilities
Yeah, 3
where
more possibilities.
2
are
girls
there.
are corner sides of the bench.
Okay, this is girl.
Girl,
These 2 are
boy,
boys.
girl.
Let's say
Yes. Like
girl,
that 4 combinations I'm getting.
girl, boy, and girl, like that.
Yes, sir.
4,
Not 4, 3.
3 more, yes, 3 more.
3 more.
Yes,
Yeah,
sir.
3 more. 3
Yes,
more.
sir, I
These
too
boys
got the
can
same,
change
sir.
now.
3.
These 2 boys couple, this couple
Yeah.
will move on. This pair 3 times.
5
they
into
can
4
move
factorial
to
into
the
4 factorial. I
other
was
position.
getting, sir.
Okay,
Yeah,
if we
even I
take
got 5 into 4 factorial into 4 factorial.
Yes.
Yes, sir, that's why I got this question wrong.
This pair of boys are there now. This will be in 3 ways they will move. Here,
if we place girls at the odd places, then no such possibilities at even places. Let's say we are placing, if I'm placing the first girl here, then
no,
also
this
we
way
can
is
do it.
not possible. Yes, that's what. And one more way will be there.
Oh no, it won't work, right?
This,
1, 2,
this
3, 4.
pair will move to the right. 2 boys
We
pair.
can place these 2 boys
Girl
from
should
back side.
always be in corner side, 2 girls.
2
No,
combination
yes,
for
girls
this
are
one, sir.
always in corner.
There will
Okay,
be a
so
3 more pattern
okay,
only.
so
Yes,
these
sir.
Next,
Factorial into
girl.
factorial. That's fine, I think.
Next pattern will be girl, boy.
2
girl,
boys can be
boy,
placed in the
boy.
middle.
Okay, yeah, we can consider these 3 cases. 2 boys here, 2 boys here, right?
Yes.
Yes.
These
Okay.
2 boys
And the
pair.
same case from back side, sir.
From back side?
Yes, sir.
How? Back side.
Put the boys,
Can you please keep the
leave the last place and put the 2 boys together.
girl?
Yes, sir.
Yeah, that's what we have considered. 2 boys here and 2 boys here.
Yes, sir. And 2 boys in the middle.
Yeah, these are the 3 cases, right?
Yes,
taking.
yes, sir. Yes, sir. These are the 3
So it
cases.
becomes 5 times.
Yes, sir.
Yeah.
Yes, sir.
Yeah, then that would be the correct one, right?
Yeah,
Yes, sir.
so
Yes, sir.
but we got wrong.
Yeah.
So that would be.
I have a
Yeah.
doubt in this question, sir, but now it's cleared.
No, the way I got this one is that when we says no 2 girls should be shit together, I took it as 2 factorial, and then the remaining is 4 factorial into 4 factorial. for girls and boys if it was a normal arrangement without any conditions. And that's how I got. I don't know whether that's the right way of doing it.
So for this answer, it should be no two girls and no two boys should sit together, right?
Yes.
Then that
Yeah,
should be
then
the
then it is.
Okay.
This answer is true.
So is the answer
So
wrong
it
here?
should be,
Yeah, answer is true.
here we
Sir, we have to
calculated,
consider the round table also in this, na, sir?
excuse me, here we
Yes.
calculated four arrangements in which girls cannot sit together, and then calculated the number of ways we can place boys and multiplied it with 2.
Sir, can we not use Bayes theorem here?
Bayes theorem permutation combination, how can you use it?
Okay. Because
Bayes theorem is
he's asking
We are
no
not
two
asking
girls.
probability.
We're not into probability. We're only in permutation combination, week 5, 6.
Oh shit, yeah.
So
Yeah,
What
so
is the
it
final
would,
answer? It is 5 into 4 factorial into 4 factorial.
yeah, it would be 5 times 4 factorial times 4 factorial. Yeah.
Okay.
okay, so we calculated the number of places boys and girls can be placed and multiplied it by 2.
Multiplied by 2.
So I just said first we calculated a number of situations and conditions when we can place girls and boys according to the given condition, the question, multiplied it by 2 as per the we were getting result.
Yeah, that's the wrong one. We
Sir,
have to
what will
consider
be the
cases.
answer? 2 into 24 square, no, sir?
5 into 24 square.
Sir, can you explain it? I missed, I think.
Okay. See, 2 into 4, we know these two cases, right?
Yes, sir.
Another case could be that girl at the first place, then 2 boys, then girl, boy, girl, boy, girl. That case is also valid, right? In that case, also no two girls are sitting together. Similarly,
yes, sir. Yes. Because it is row.
Yeah. In that case, also no two girls are together. And in that case, also no two girls are together. So that total 5 pieces, right? So that's 5 times 4 factorial times 4 factorial. This is the answer, right?
I have one doubt here. When will we consider these girls will interchange their positions? That ways, when will we consider?
We are considering it. 4 factorial is the ways to arrange these 4 girls.
We are already arranging.
That's what 4 factorial means.
Here order matters.
Yeah, order do matter.
Please explain.
Because if you are making G1, G2, G3, G4, and B1, B2, B3, B4, right? In other case, you are making G2, G1, G3, G4, and B1. These two are different cases, right? So order do matter if I place G1 at the first or G2 at the first.
Okay.
These two are different cases. So we are selecting family members one after the other or together. So yeah,
simultaneously.
Yeah.
Without replacement, because you cannot select one member. You cannot, make one member available at 2 places. And order do matter.
Sir, please consider for the round table.
Round table means?
Consider that they are sitting in the round table. And no
Round
girls, the
table.
boys.
Yeah, we'll cover it. Just one last question before we go there. Okay, question number 19. Any doubt in it?
Yes, please.
Yes, sir.
I felt it is the only difficult question.
Okay,
Quite similar to the last question which Usha ma'am did when she finished her revision session, but still we couldn't get the answer right.
Yeah, similar question will be in Quiz-2 as well. Okay. Okay. Suppose
It's the difficult
box.
Sir, I was not able to make the event set.
Okay, let's see. There is in box A, there are 6 red and 8 black balls, right?
Yes.
Okay.
In box B, 5 red and 4 black balls, right?
Okay.
5 red and 4 black, right?
Okay, box B, box A. And then a ball is chosen at random from box A and placed in box B. And then we are choosing a ball at random from box B. Okay. So there are only two possibilities, right? Let me define the event. Even that red ball is transferred to box B, or E2 black ball is transferred, right? These two are the only possibilities. Next is, what is the conditional probability that a black ball was transferred from box A to B, given that the ball chosen from box B is red? Okay. So let's say event E is that the ball chosen is red from box B, right? Okay. So first of all, probability of red ball being transferred, it is same as selecting the red ball from box A, right? Which is nothing but 6/14, right?
Yes.
Selecting black ball from box A, it is same as transferring black ball to box B. So it's
8 by 14.
okay. Now consider it. If red ball is transferred to box B, it means now box B has 6 red and 4 blacks, right? What is the probability that ball chosen is red from box B?
6 by 10.
6 by 10. Let's switch. Yeah. So what is the probability that red ball is chosen given that black ball is transferred? So it has one additional black ball. That's 5 by 10.
5 by 10.
Right. And I think you have to find the probability the black ball was transferred given that ball
Chosen is red.
Okay, so given E, you have to find E2, right?
Given E over E1. Right?
Given E, you have to find E2. Given that ball chosen is red, what is the probability that black ball is transferred? So it's simply using the formula for conditional probability. This is this, right? In numerator, you can apply multiplication rule. You know probability of E2, you know E given E2, right? The probability of E. Probability of E is nothing but the addition of two cases, right? Red ball is transferred and red ball is chosen, or black ball is transferred and red ball is chosen, right? Again, you can apply multiplication rule over here. You know all this value and just plug in it, right? Plugging in, you will get the values, right?
Sir, can you put the screen little up? I cannot see the last line. Can you scroll up, sir? Scroll up, sir.
White code, I don't think I can. That's it. Which line you cannot see?
The last line, sir.
Okay, in last line, we just did the multiplication rule. So E intersection E1, you can write it as E given E1 times probability of E1, right? Plus E intersection E2, you can write it as, right? You can write it as like that. So you know these values, E given E1, E1, E given E2. You know all these four values. So you got the denominator, you got the numerator. That's your answer, right?
Can you briefly tell what is P of E?
P of E is that ball chosen is red from box B.
From box B. Then what it will be? 6 by 10.
Yeah.
Which
If
values
it is given that red ball is transferred. See, if I am transferring red ball from box A to B,
okay,
then I will have 6 red and 4 black in box B. So in that select choosing a red ball, we have 6 out of 10 probability, right?
That is okay. P of E.
P
Probability
of
of
E,
ball chosen red from B. What values it will take? Can you please tell the values?
it is same as this, right? There are only two possibilities, that ball transferred is red and then chosen is red, or ball transfer is black and chosen is red, right? Then applying the multiplication rule, you can simply plug in these values, right?
6 by 10 into 6 by 14.
Yeah.
Now, how to visualize this? I am thinking, apart from the formulas, how to visualize in general.
Yeah, sir.
How
So
to
the
visualize.
question का जो last line
Yes,
है
sir. If we are able to make the events, then it looks easy. But
See, if you consider the Venn diagram, something, there are two possibilities. Either you transfer red ball or you transfer black ball from A to B, right?
Yes.
And this is your event that ball chosen is red, which is event E, right?
Yes.
So it is nothing but intersection of this area and this area, right?
Yes.
So that's what we did. And then we simply applied the multiplication rule. So first term can be written like this, second term can be written like this. And we know these all four values, right?
सर एक्चुअली जो लास्ट लाइन है ना उसमें समझ नहीं आ रहा कि व्हाट एग्जैक्टली द क्वेश्चन इज आस्किंग.
Actually, every question I am solving with 3 methods, so I am unable to understand.
मतलब actually it's saying ना कि what is the conditional probability of black hole transfer. If this line is like not giving any clarity कि what exactly it is asking.
It's straightforward. It's black ball transferred from box A to B. You have to find the probability of this thing, given that from box B, red ball is chosen. So I've defined the three events, right? Ball chosen is red, black ball transferred, and red ball transferred. So I have to find something E given E2, right? Or E2 given E. These are the three possibilities. These are the three events I made, right?
sir, will you also take the graded assignment question, sir? I have one doubt, sir.
Yeah, after this. Is this clear or still any doubt in it?
It is theoretically it's okay, but still unable to visualize what's going on.
Sir, can we do this in tree diagram?
In tree diagram?
Yeah, sir.
Okay, let's try. Okay, so initially, okay, something. Okay, so first from box A, we can either transfer red ball to box B or black ball, right?
Yes, sir.
So the probability that we transferred, wait, need to check the numbers again. It's 6 red and 8 blacks and 5 4. 6 red, 8 blacks in bag A, right?
Yes, sir.
And 4 red and 5 black in box
5.
B. So probability that red ball is transferred is 6 by 14, right? Because out of 14, only 6 balls are red. And black ball is transferred is 8 by 14. Is it clear till this step?
5
Yes,
red
sir.
and 4 black, sir.
4 blacks?
B is 5 red and 4 black, sir.
In second box,
Second
5
box.
red and 4 black.
5 red and 4 blacks, right?
Yes.
Is it clear now? Till this step, it is clear, right?
Yes, sir.
Okay, after transferring it to bag B, okay, see if red ball is transferred, my bag B has 6 red and 4 black.
Yes.
If black ball is transferred, my box B has 5 red and 5 black, right?
Yes, sir.
So probability that red ball is chosen or black ball is chosen. So red ball is chosen is 6 by 10.
10.
Black ball chosen is 4 by 10. Here it's again from box, like after transferring the black ball, to box B, you can choose red ball with probability 5 by 10 and black ball with probability 5 by 10, right? So what is the probability that red ball is chosen from box B? It is these two cases, right? Red ball is transferred and red is chosen, black ball is transferred and red is chosen. So it is 6 by 14 times 6 by 10 plus 8 by 14 times 5 by 10, right?
Yes.
This is your denominator. And your numerator is this thing, that the black ball is transferred, the red ball is chosen, right? There's nothing but 40 over 36 plus 40, right? Is it clear?
This 8 by 14 and 5 by 10, how did you get? Can you please repeat this one?
Okay, so you have to find the probability that ball transferred is black, okay, given red ball is chosen from box B. Okay, so it is nothing but the intersection of these two. Let's say this event E1, E2, right? Probability of E1 intersection E2 divided by probability of E2, right?
Okay.
So your E2 is nothing but the red ball is chosen. So it is the addition of these two, right?
Yeah.
These two are this. Your numerator is the intersection of these two, that the ball transferred is black, which is this, and red ball chosen, which means only this case, right? So 8 by 14 times 5 by 10, right? Is it clear?
Yes, yes.
Yes, clear.
Okay. Yeah.
Thank you,
Anyone?
sir.
Any other doubt? Yeah.
Sir, that round table.
Round table. Okay. So what
From
question?
question number 17, we can think of if it is a round table, what will be the
Yes, if it is a round table,
girl and boy, or two girls are sitting together like that? Two options.
okay, so in round table, we have we have a lot of questions for round table as well. Okay. Yeah. The revision session slides are also available in supplementary for that. Many of you may have gone through it. This is for week 5, 6, and this is for 7, 8.
Okay, sir.
So 5, 6, yeah, we have also embedded the solution questions done by me. Okay. Let's see some round table. Okay, see, yeah. At a party, there are two groups, okay? One group of 4 English-speaking members and their president. And other is of 4 French-speaking people and their president. So in total, there are 10 people, right?
Yes, sir.
So 10 objects in round table in circular permutation can be arranged in 9 factorial ways, right? N minus 1 factorial.
Yes.
Okay, so that's simple 9 factorial. Now let's plug in some conditions. Condition that no 2 French-speaking people should sit together, right? So what
And
we can
minus
do,
1 into and like
yeah. So for what we will do is we will first place these French-speaking people, these 5 French-speaking people, right? We will arrange them in circular permutation, which we can do in 4 factorial ways.
yes, sir.
So suppose these are the French, F1, F2, F3, F4, and F5, right? Now, in between them, we have this place, 2, 3, these 5 places, right?
Yes, sir.
So we can arrange the English speaking member in now in 5
Factorial
factorial
ways.
ways, because here the circular permutation won't work, right? In circular permutation, what happens is this A, B, C, these two cases considered as same, right?
Yes, sir.
But here what will happen is A, B, C, it won't be same as this, because here A is between F1 and F2, and here A is between F2 and F3. So these two are different cases as well. So that's why we take linear permutation and not circular to arrange the English speaking persons.
Okay.
So that's 4 factorial times 5 factorial. After that, I think we have one more question on that. Yeah. President of both groups are seated next to each other. Right. So what we did is we considered both the president as one single unit. Right. So in total, there are 10 peoples, right? 8 members and 2 presidents. We consider both the president as one single unit. So in general, we have only 9 members now, right? This 8 and plus 1, these 2, right? I can arrange these 9 members in circular permutation in 8 factorial ways. Plus these 2 presidents can also interchange themselves, right? In 2 factorial ways.
Sir, if it is a linear arrangement, I think 8 factor multiplied by 2 factor is correct. But if it is in circular thing, will it not affect or will it remain same?
In linear, it would be 9 factorial times 2 factorial, right? This 8 members and this one, 9 objects we are placing in circular can be done in 8 factorial ways, right?
No, because if the 2 presidents will sit together, let us say a first position and second position, they are sitting together, and yes, 8 people will sit. So I will consider in 9 factorial ways. No? 8, baki 8, 9 factorial ways, then multiply by 2 factorial ways, because they can interchange first and second together. So that will become 9, 8 factorial, 9 factorial multiplied by 2 factorial.
Yeah.
But if it is in circular, then you are just making it 8 factorial by 2 factorial. Is it the difference?
Yeah. See. So I think most of you haven't seen this PDF.
We attended the session, so but
yeah, after
this
session
point
we
I
have
was
uploaded
missing.
it. Okay.
I have
After
one
the
doubt,
session
sir.
we have uploaded it in the next
Graded
week.
assignment, sir.
Sir, can you please explain once again that 5 factorial into 4 factorial? You've taken that linear.
Okay. So see what happens is generally when we arrange objects, right? Suppose A, B, C, right? And this A, B, C. These two are same cases, right? That's why in circular permutation we have n minus 1 factorial ways and not n factorial ways. Because
Yes.
it still reads as ABC. It also reads as ABC, right?
Yeah.
Okay. So what happens is if I place, so this is the first French person, this is second French person, this is third, this is fourth. Okay, only third, right? And again, if I am place F1, F2, F3. Now these two cases are different because A is between first and second, but here A is between second and third. So now these two become different cases. Earlier it were the same. So that's why it has become linear permutation now and not the circular permutation.
This is because you're talking about people. I
No,
mean, why we have taken linear?
It matters. Now their position matters. Earlier it was circular, it doesn't matter A, B, C or A, B, C, right? But after placing the French persons, it do matter that A is between F1 and F2 in this case, and here it is between F2 and F3. So these two are now different cases. These are no more the same, right?
In this case, sequence will matter, sir. Na?
Yeah, in this sequence will matter.
But in the first case, sequence will not matter, na, sir?
Yeah.
First question when we started with it.
Yeah.
Factorial 9.
Yeah, because that's circular permutation. But here it becomes linear because we are able to differentiate the positions. This position we can differentiate it, right? Okay. Anyone, any other doubt?
Yes, sir. In graded assignment 8, question number 1. Sir, what
Okay,
I'm
how
doing?
did you? Yeah.
Yes, sir. In my question, there is 17 matches, and
Okay.
he has taken 6 5-wicket haul, and the last 5-wicket haul is the 9th one.
Okay.
So what I did, I fixed the last 5-wicket haul at the 9th place.
Okay.
And I'm left with 8th place.
Yeah.
And in these 8th place, all the 5-wicket haul will come. So
yeah, remaining 6 will come. Yeah.
8P5.
No, remaining 6, right?
6. Sir,
yeah,
only 6 5-wicket hauls are there. I have already
only
taken.
6. Okay,
yes,
yeah,
sir.
only 5.
I have.
Yeah.
So 8P5.
Okay, 8C5, right? We're choosing them.
Choosing them.
Yeah.
Sir, we are arranging.
No, selection, not arrangement.
Okay.
Sir, I couldn't get this problem. Could the G look it up? Can you please explain this, sir?
See, so what happens in it is,
sir, if we are selecting the 5 places,
there are 17 matches in total. Okay.
Yes, sir.
6 5-wicket haul matches.
Yes, sir.
And 11 others, right? Now I did the first match, second match, so on. And in the 9th match, I should get the last 5.
Last 5.
It could be any, right?
Yes, sir.
It should be the 5-wicket haul match. So in the first 8,
yes, sir,
I should have done the 5 5-wicket haul matches.
Yes, sir.
So out of these any 8 places, the 5-wicket can come at any of the 5 places.
Yes,
so
sir, but we can arrange them, sir.
No, it doesn't matter. We are not arranging this 5-wicket haul. It's not like first 5 wickets, second 5 wickets. It's only 5-wicket hauls. We are not arranging them in any sense. We're just selecting it.
Look, sir, if we arrange them, then we can suppose I am getting 5-wicket haul on in the first match, or I'm not getting on the first match, I'm getting it on the second match. So
it doesn't matter. Till late, I should have only 5.
Okay, sir.
In any way, it doesn't matter in what order I get. I should have only 5. I should get all 5 in the 4 to 8, 1 to 5. It doesn't matter.
Order doesn't matter here.
Yeah.
That's why we are selecting this 5
Yeah.
place. Okay. Thank you, sir.
Sir, it's a question.
Okay. Thank you, sir.
Okay.
11.
Sir, I have a doubt. Can I ask?
Is someone asking from this question or not?
No.
Okay.
Sir, question 11 and 12 in the same.
Yeah. Let him complete first. Yeah.
Sir, a question. It's not from activities or other. Is how many total possibilities are there to select 3 numbers from 0 to 9 where the repetition is allowed? I don't know if this question is valid or not, but I am very confusing with this. Can you just?
Okay, what's the question?
How many total possibilities are there to select 3 number from 0 to 9?
3 digits it should be, I think.
Yeah, where repetition is allowed.
3 digits you have to select, right?
Yes, where repetition is allowed.
You have to select or arrange?
We have to select.
Select.
Yes.
So you can select any of the 10 at the first for the first. Repetition is allowed, right?
Repetition is allowed.
Selection, repetition. Okay, so it's simply 10 cube, right? You can select any of the 10 at the first, any of the 10 at second, any of the 10 at third.
But sir, there will be some common things.
Common things like
0 0 1 1 0 0 0 1 0 like that. I don't know.
1 0 0.
Am I
We were selecting something like that.
What sir?
Okay, let me just. So your question is, we have to just select 3 digits.
Yes.
Right?
Yes.
Order does not matter. Something like that, right?
Yes, yes. Order doesn't matter, and the repetition is allowed.
Okay, that's something I think bit beyond the syllabus for this for now. Okay, it's not.
Okay. Okay, sir. Thank
not
you.
going to it. Yeah.
Sir, is it possible? I want to just know.
Yeah, it's possible.
Okay, sir. Thank you.
That's it. See, permutation combinations, it's different subject. If you want, you can just Google combinatorics and you will see a lot
Okay,
of heavy books written on these topics. It's not that you're not bounded to these 2 weeks or these 7 lectures only. There are a lot of many possibilities.
Okay, sir. I will look for it.
Okay.
Sir,
Yeah.
could you please go to question 11? Please?
Question 11 and 12. Okay, how did you approach this one?
फिर जो ट्री डायग्राम वाला करके ना मैं एक्चुअली एक कंफ्यूज कर रहा हूं कितना क्या करता हूं
Yeah, how like what all like how did you draw it? What all possibilities did you take? Because I have done this question 3 times already in the previous sessions. So this is some either it would be rainy day, right? Or non-rainy day.
Yes.
After that, you can split it into heavy traffic or not heavy traffic, right? That's what you did.
Oh yes, sir.
Okay. After that, it could be late for school or not late for school in all the cases.
Yes.
Right? And you have to find the probability that on a random day he late to school. Okay. First, find the probability that he is late for school, right? So what all are the possibilities? This case, this case, this case, this case. You have to add all the 4 cases, right?
Yes,
It's rain, heavy traffic, late. Rain, no heavy traffic, late. No rain, heavy traffic, late. No rain, no heavy traffic, late, right? These are the possibilities of being late, right? You can compute it. Simply add. Right?
Yes.
After that, what is the probability that it rained that day? Okay, so we are given that he is late for school. We have to find the probability that it rained that day, right? So for that rained, we are only bounded to this now. We have to working on that. So only first 2 cases come, right?
Yes.
It rained, then heavy traffic and late. It rained, not heavy traffic and late, right?
Yes.
That's your numerator part. Right? You have to, in general, you have to find this, right? So probability of R intersection L divided by being late, right? Being late is all these 4, right? These 4 scenarios. Rain and late, only these 2 possibilities, right? You just simply plug in the values and solve it.
Yes, sir.
So for most of these questions, tree diagram is the best method, I feel so, because
no, it's not the best. It's up to you. If you will do it, like if you practice by contingency table, you will find it easier. If you keep practicing by tree, you will find it easier. So you're up to you.
mean,
but yeah,
there are more chances of going wrong somewhere if we just miss one step in the other steps. But this thing, if
yeah,
you get
tree
the
diagram,
math
I
right,
also feel it's easy because I do by that. But yeah, it's everyone's personal opinion. There are many students saying that matrix contingency table method, they find it the best. to do.
Which method do you prefer?
I prefer either the tree or the normal multiplication law of probability. I don't generally go for contingency table.
So
If I
for
feel
the-
that's a bit
in this
complicated.
case, if we consider rain as late,
Yeah.
we should not consider this heavy traffic burst of what is
So we-
what is deployed, we should multiply that with 2. So we should not consider the other thing.
Yeah, in tree diagram, everything is clear, right? You can simply see which all probabilities you need. Like rain intersection late. So I am only focusing on rain and the late part.
Okay. I no need to consider the traffic, what in between that.
Yeah, traffic doesn't matter, right? It's only R and L should be there. Okay. So yeah, you can go by tree method, you can simply go by law of the probability of that. But a T diagram, I think it makes a bit clarity. Okay, anything else?
So that first question, I'm still not clear. So that cricket, you were saying, no, I'm not able to understand the question.
In the first question. Okay, so here he has taken 4 5-wicket haul in his last 15 matches. Okay. We are selecting his record, like we are selecting his matches one by one and analyzing it. Okay. And we analyze one match only one time, not more than that.
Okay.
So what is
This
the probability?
4 5-wicket haul, in a sense, he has taken 5 wickets in the 4 matches.
Yeah, in the last 15 matches, he had done it 4 times. Okay. Yeah.
Yeah, he has taken 5 wickets in 4 matches.
Yeah, out of these 15.
Okay.
So for 11th one to be his last 5-wicket haul match,
Okay.
what should happen is in the first 10, I should have analyzed his first 3 5-wicket haul match, right? Remaining 3.
Okay.
So that can be done in, like I should select 3 from this 4C3 base.
Yes.
And remaining 7 from the other 11 matches, right?
11. Okay.
So 4C3 times 11C7. But in general, total number of bases 15C10 to select any 10 matches out of 15.
Yeah, that is the total sample space we had.
Yeah. After that, like after doing 4 in 10, we are left with 5 more analysis, right?
Yes.
Out of which only 1 is 5-wicket haul.
Yes.
So for 11th one to be 5-wicket haul, it's 1 over 5 chances, right?
Correct.
So that's what it is.
Okay, got it, sir. Sir, I have 1 or 2 other questions. In practice assignment 7.2, second question.
Practice assignment, yeah.
7.2.
Or someone has this 12th question as well, right?
Yes, sir. Actually, उसका tree diagram बस draw कर दीजिए sir.
Tree diagram, okay.
because इसमें ना ज़्यादा clarity मिल जाती है कि हाँ सच में कहाँ पे गलती हुआ है.
See, either I go to shop A or shop B.
Yes, sir.
After that, either I pick 2 red shirt from here or 2 red shirts from here. That's it, right? And here you can say not picking 2. Something like that. This event is nothing but the complement of this one always, right? Their probability always add up to 1. This and this, this and this, this and this, right? So going to shop A, it's I think half and half. If he goes to shop A, what is the probability of selecting him 2 reds? I think it's something NC2 or 2C2, right?
So, are you asking me to read the question?
No, I'm just asking, is the method clear? Like that's the tree diagram. I can either go to shop A or shop B. After going to shop A, I can pick 2 red or not pick 2 red. In shop B, again, I can pick 2 red or not pick 2 red, right?
Yeah.
These are the only possibilities. After that, you have to find the possibilities of 2 reds being picked. And then the conditional of from shop A, I think, right? Then you are bound to this only.
So last में जो दिया है ना जो if the probability of given is 6 and then we find the value of n. So in that case I need to like was persist from the south paying 6 by 7. So
Yeah.
I need to only fix that value. No? Could you please go to the diagram, please?
Both petition purchase are red. Probability is from shop A. Probability it is from shop A. Both are red, right? So it is nothing but intersection both red divided by probability of two reds, right? So two reds is these two, right? And A intersection 2R is this one only, right? Within A 2R. This is.
Okay.
So for denominator, you need to add these two. For numerator, only this one, right? And this probability is given to you 6 by 7. You can find the value of n.
Yes,
Right?
sir. Yes, yes. Thank you, sir.
So we can say that if A and B are independent evens, P of A intersection B, we can say is P of A into P of B, sir. So if A, B, C are independent evens, can we say that P of A intersection B intersection C as P of A into P of B into P of C?
Yeah, you can say. You can say if they are independent, you can say. Okay. Yeah. Anything else, anyone?
Yeah, sir, one question is NC3 equals NC2. They asked us to find the value of n. So by trial and error, I got 5. But is there a method of finding how?
Yeah, there is method. NC3 equals NC2.
Yes, sir.
So just apply the formula. Right? Numerator gets cancelled out. So you got 1 times 3 times 2 factorial n minus 3 factorial, right?
Yes.
And there are 2 factorial n minus 2 times n minus 3 factorial, right?
Yes.
You can cancel this out.
N minus
Cancel
3,
this.
okay.
We are left with 1 by 3 equals minus 2.
Okay, okay. Got it. Then one question, practice assignment 7.2, sir.
Yeah.
This numbers Jersey. Yeah, this is the one. This 0 to 99. So even number I got 50 and odd. So the first question I got the answer. That is divisible by 3 will be 33 numbers.
34, right?
34, yeah.
Yeah.
And that is P of A plus B of B minus P of A intersection B. That's what you have to apply in that. No?
Yeah.
But the second question, I'm not getting it, sir. What is the probability that you'll choose a Jersey number, neither divisible by 3 nor by 5?
Sir, divisible by 3 is 33 now, sir. 99
no, it's
divided
0
by
to
3.
99. 99 divided by 3 is 33.
Yeah.
But 0 is also here, right? 0 is also divisible by 3.
Okay, sir. Thank you.
So see, this is the numbers, even numbers. This is divisible by 3, okay?
Yes.
You have to find neither this region nor this region, right?
Okay.
So it would be that area.
Okay.
This is nothing but complement of these. You know this probability in first part, right?
Yes, yes.
So just simply do it. 1 minus this.
Yes, but they are getting it as 0.53. See, A union B is whatever is divisible by 3 and 5.
Yeah.
So
3 and 5, yeah. 3 or 5.
3 or 5. So we add, okay.
There are only 7 numbers.
Okay,
3 or 5 means 3 times 5, 15. Any number divisible by 15 will be divisible by both. Right?
So
Okay,
here, mutually exclusive and mutually exhaustive in some conditions we will say that it should not exist. So why we are saying that we could put up clarification.
Mutually exclusive means Mutually exclusive means disjoint, like this, event A and event B. If event A occurred, B cannot occur. If B occurred, A cannot occur. That's what mutually exclusive is. Okay. Mutually exhaustive is, suppose I toss a coin, right? Possibilities are head or tail. I would get one of these outcomes for sure. So that's exhaustive.
So, do we need to consider these factors when solving problems, sir?
Not really, but yeah, for your course, I think exclusive is a bit important than exhaustive.
Okay, so if exhaustive, do we need to consider some terms?
No, exhaustive, it's just a basic property of sample space. That sample space should be mutually exhaustive. It means the result of your outcome should belongs to your sample space, right?
Okay.
Like if you're rolling a die, your sample space should be this. If you write your sample space as this, then it's not exhaustive, right? Because you can also get 5 or 6. So in that case, it won't be your sample space.
So the doubt I asked for the Jersey thing, the
Yeah.
workings which you have, the feedback, it is not visible in my practice assignment. Only the answer was given. Where can I get this answer?
It is for everyone, right? Whenever you
Yeah,
click on check answer,
but
you
in
will get
the
it.
because it, I do not know. It is not in my. It's not in the feedback. Do we have any separate?
No. After clicking on check answer, you aren't getting it.
Yes, sir?
After clicking here, you didn't get
Yeah,
the
I did that. For other questions, a couple of questions, I have the answer. Even the last marathon, I have. For this question, I didn't have. Not this
just
exhaustive thing.
this one.
Yeah, for this one.
Just input some random values.
Okay.
And then click on check answer, you will get it.
Okay, sir, I'll do that.
Okay, because yeah, there are some feedbacks which are designed like that. It won't be shown to you until and unless you attempt that question.
Attempted. Okay.
So that's also a condition. Yeah.
Yes, that must be the reason. Okay, sir. Thank you.
Okay. Anyone? Anything else? Or shall we close for today?
Sir, I need some advice.
Okay.
Actually, week 5, 6, 7 मैंने बहुत अच्छे से कर लिया था. मुझे
Okay.
क्वेश्चंस भी बहुत अच्छे से बन रहे थे. The only thing is when I again tried it, I forgot how I did it. मतलब I
It's all
think
about practice. Yeah.
I don't know. I was really good at it. मतलब I thought कि week 8 बचा हो बाद में करूँगी. But now when I'm trying, it's very difficult for me to come back to the previous version.
Yeah,
How
it's all
should
about
I practice
practice.
it? Because time is very less.
Once you do a sitting of
I
I will do.
wanted to ask the same thing, sir. Any last minute tips that you can give?
Yeah, I need, sir.
Considering there's
Yeah,
only
just
2
stick to the
weeks
method you are working with. Don't switch your methods. And yeah, it's better to leave some questions rather than spending 10-15 minutes on that.
So practicing these assignments, non-graded ones for the weeks is enough, sir, or do we?
You should be clear with concepts. See, practicing question, even if I give you 100 questions, it still won't be enough. There are a lot of questions. It's all about the concept. Once you're clear with concepts, you will be doing thousands of questions just without even.
So should I just watch the revision session by Usha ma'am and then take
Yeah,
up this
that would work.
assignment
Yeah,
and
you
graded
can do.
assignment?
Yeah, you can do. I think Usha ma'am session, it's a complete revision. You can get it.
Okay.
Sir,
Yeah,
almost the portion is covered in mock. If I go through last
mock,
minute, rest all I did, sir, but my mind is blank only.
this mock,
Same.
we changed it from the previous mocks. We designed it to keep it in the same format as the current Quiz-2 only. Okay.
Almost all the portions is covered, no?
Yeah,
What are
and we are covered all the weightages also. We tried to match up, and difficulty level we also tried to match up in some way, but yeah, it couldn't be matched perfectly.
Okay, sir, I'll try.
So yeah, and yeah, just there's nothing like you have to attempt question 1, 2, something like that. You can switch to question 5, 6, and then question 10. It's up to you.
Yes,
and yeah, sometimes it's better to leave one question than spending 20-30 minutes on that, right? You will be instead of spending, suppose this question I got stuck, right? Suppose this question. So it weighs only 4 points. So instead of spending 15 minutes over here, I can do these two questions in 5 to 10 minutes, right? So
question paper is lengthy, or it's we are able to finish it in time?
yeah, you'll be able to finish in time if you don't get stuck in between, mostly.
And questions will be 19 like this in mock.
Yeah, only 19 and only 4 optional questions, same pattern.
Okay. Do we need to revise more than this covariance question you have given or something?
Yeah, weightage for week 1 to 6, it's 50%. For 7, 8, it's 50%. So it could be anything.
So 1 to 4, I mean, ज़्यादा आएगा or just 1 or 2 question?
That we can't disclose. It's week 1 to 6 is 50. That's it.
Okay.
Sir, when I was doing the timed mock, the last question I just answered, I mean, I just solved it and I was about to answer. The time already ran out the 1 minute and I was not able to submit. So in the final exam, just in case, I will not, I mean,
It automatically gets submitted.
Yeah, okay.
It's not like that. Yeah, the system automatically stores your answer. Right. Whenever you select one, it gets saved.
Sir, one last question. When we say 4C, 4 plus 4C, 3 plus up to 1, we
Yeah.
write it as 4 to the power of n, is it?
2 raised to the power 4.
2 raised to the power of 4.
Yeah.
Yeah. Do we have a formula for that? So for, I mean, you solved anything on that, or it is just a formula we have to remember?
Yeah, it's the property of binomial actually.
Okay, okay.
Yeah, we will cover that in week 11. So, yeah.
Okay, okay, okay.
Okay, then
Thank
I
you,
think.
sir. Thank you very much, sir.
Yeah.
Thank you.
All the best.
So,
everyone.
Thank you, sir.
Thank you so much. And it's
Thank you,
week
sir.
1 to 8, right? Sorry.
Yeah, week 1 to 8. Yeah.
Okay, thank you.
Yeah, thank you very much, sir.
Thank you, everyone. All the
Thank you,
best.
sir.
Yes, bye.